Welcome to the second part of the Image Processing and Image Analysis workshop. Now we start with a fresh geodig to pick up everybody who might have gotten lost during the first part. I, for my part, also started a completely new cloud computer to pick also those up who didn't do the first part of the workshop. I'm here on the desktop of the cloud workstation, or of my cloud workstation, and I just double-click geodict and wait until it started. Please don't click it multiple times because then it will start multiple times. Just wait until it starts. It might take a bit longer or shorter than in my case, but just wait until it starts. I maximize my geodict, and the first thing that I will have to do here is to set up the project folder. For everyone who also joined the first part of the workshop, this will not be necessary, but it will be necessary for everyone who just joined. And for this, I right-click here on my project folder, which is currently Home Geodict My First Geodict project. Right-click on that and then click on Select Project Folder. The project folder for the workshop is already prepared. It is here in the folder Workshop Materials. Double-click that one, then double-click the workshop or the WS Image Processing and Analysis. And in this folder, which contains all the data for our workshop, is again a project folder which is prepared for this workshop. So double-click the project folder in here and then click Choose below. And then you can also see that here the folder changed to Image Analysis and so on project folder. So the folder is correctly selected. Now we want to load the data which we just saved. For this, please switch to the module Import GeoVol. For this, here up in the top bar, click on Import and then click on Import GeoVol. So import GeoVol. Click on that one, and then you will see that the module here in the module section changed, in my case, from FiberGeo to Import GeoVol. It should be Import GeoVol for everyone now. In this module, just click on the Browse button to browse for the file. Everyone who already joined the first part will here have saved a file cathode NMC cropped GRW. That's the file we just saved. For everyone who didn't join the first part, please switch one folder up, and then there is a folder results M2M, and in there is also a file which I saved beforehand, so you can also start with that one. I take the one from just a moment, select the file and then click on Open. Since this is now a geodict raw file, all the data here is automatically entered. This means the geodict knows the size in all directions and also knows the voxel length, which is here 398 nanometers. So you don't have to change anything here, just click on Image Processing and wait for the Image Processing dialog to open. So I maximize the dialog so that we can see everything as we want, and I zoom slightly in. I do this with holding and dragging the right mouse button until it is as large as it can fit inside of the window. Now we want to start with the image processing, and first we want to get rid of the noise in our image. I drag the visibility slider for the segmentation a bit down to see more here of the data and the noise. So if you zoom in here, you can see that there is quite a lot of noise inside of the grains. They don't really look good. There's a lot of noise. So we want to filter the image. And for this we will use the non-local means filter, which is a pretty good filter to start with. Go here on the left side to the image processing tree and then go down to image filters. And the first one you will see is the non-local means filter. We want to use that one. So click on the small icon here on the small arrow to open it. But there are some parameters, a patch radius, a search window radius, and so on. You might not directly know what to enter here. And for this, there is a filter preview where you can try out several parameters and then select the one which fits best. So we click here on the preview button. So image processing, image filters, non-local means filter, and then click the preview button. Now you get a preview window. I again maximize this one because it's a bit small. And we don't see anything in here right now because we didn't create any preview yet. Down here in the left area, you can select the parameters for your filter. So the parameters which we want to vary. We want to start with the patch radius, which is the first parameter here. We want to start with a radius of 1, which is the smallest one, and go until 3. So keep the 1 here and then enter 3 for the second value. Then we keep the other values at default. Only for the strength value we will change it a bit. We will switch to 0.4 since often 0.5 is a bit strong. And then click on Create Update Preview. And now the preview windows are created. Now you can see that the previews are very small. For this we want to increase the zoom factor to see more in there. So up here, select the zoom factor to 200 or even 400%. I stay with 200 because otherwise they get quite large. It's still quite dark as in the beginning of the workshop, and this is because the gray value range is not selected properly. We will select the range now. You can do this up here under gray value range, and now we select around the range which is also selected in the image processing dialog, which goes until around 11,000 I think, and starts at around 2000. Then just hit enter and the previews will update. You can now see the result of the preview. Here on the left, this is the original, which is quite noisy. And then you see the previews for a patch radius of 1, 2 and 3. As you may probably see, the difference is not that large. Maybe for 1 it's a bit sharper than for 2. It's a bit difficult to see, but usually if the results are very similar, it's always makes sense to use the less stronger filter. So we stay with the patch radius of 1 here. Now we want to vary the next parameter, which is then the window radius. For this we go down here to varying parameter and select window radius. Here for patch radius, make sure that the one stays selected or is selected. We now want to vary the window radius from 2 to 4, so the default is 3. We vary around this and keep the rest as it is, and then click on Create Update Preview. So now we have a new preview with the original and different selections for the window radius. The original is still noisy, which is clear, and then one can see that maybe here the window radius of 2 is a bit noisier than the others, so there is a bit more to see inside of the grain, but also the others start to get blurry quite fast. So here for 4 it's already quite blurry, and if you look at it, this might be a bit noisier here for window radius 2, but it is already much less noisy than the original. So we will stay with a window radius of 2. Select that one, and now we have to change or to adapt the strength value as the last one. So for this, go here for varying parameter to strength. make sure that window radius is selected as 2. And then we want to vary the strength value from 0.1 until 0.5, which is also already selected in my case here. Then click again on Create Update Preview. The result is already similar to what we saw before, so it's a bit more noise for the smaller strength values and a bit less for the larger strength values. Here for this structure, it's a bit of guessing which one might be better or worse. They're quite similar. I think that here the value of 0.4 might be good. If you come to another conclusion, you might also select something else here. So I select 0.4. So make sure that the right combination of values is selected and then click on Close. Now you can see that the selection of parameters is now entered here in the main window. And to apply the filter for the structure, just click on Apply. This might take some time, here around 1.5 minutes or even a bit faster. If you are running a computer with a graphics card from NVIDIA, usually it will be much faster. It should only take several seconds until it finishes. Nevertheless, for the workshop, 1.5 minutes is also fine for this structure here. Now, after the filter is finished, you can directly see that the segmentation, or not the segmentation, but that the image looks a lot better here. And we do not have the noise in there, and the grains are separated a lot better. You can also see below here in the histogram that the two peaks are nicely separated. This is often an effect of the NLM filter, that it helps to separate the peaks in the structure, so to segment the faces in your data. We can again change the gray value range to see it a bit better down there. So we see it only starts at 4000. So go up here to the gray value range and enter 4000 for the start and hit enter. And then it looks a lot better. Now that the filter is applied, we want to do the segmentation of our structure. For this, we change from the image processing options to the segmentation and labeling options. Here from image processing to segmentation and labeling. Since this structure looks quite nice and might be easy to segment, we want to use a simple segmentation option. For this, we go under the global thresholding options, here under image segmentation, global thresholding. Open that one, and in there you can select different methods. We want to keep the segmentation mode to single threshold. Because we have only two materials, here the grains and the space around it, we only need one threshold between the two materials. As the default method that we selected here is the Otsu method. This computes an automatic threshold based on the histogram of the data. Often this works very well. To see the segmentation or the previous segmentation, you might have to turn up the visibility slider up here. So turn that up and then you can see the segmentation. The final thing now we want to do before we do the segmentation is to select the materials in our structure. You can select which materials get assigned to the different phases in your structure in Geodict. Under the global thresholdings, you see two materials, material 1 for ID 0, material 2 for ID 1. Here for material 0 you can just keep it as pore because it's just a pore space around the structure. And for material 2 we want to select NMC 333. For this click on the material here, which is manual, then the material selector opens, and in there scroll down until N, select NMC 333 and click on OK. Now you see that it is selected. We are ready to go now. You can just click on Create Segmentation and the segmentation is created. So below here, under Global Thresholding, click on Create Segmentation. Now everything is finished and you get a result file from the image processing, which opens here in the result viewer, and where you can see all the information what we did during the segmentation. For example, that we used the ODSIT method, and the threshold value is also shown here, and also the filters which we used during the image processing are shown. We used only one filter, which was the NLM filter. Additionally, you get some information about the structure, like the voxel length and the size of the structure and the porosity and solid volume fraction. So now we can close this. You can either do it with the X as usual or click below here on close. And we want to do the same for the image processing dialog. So just click on the X up here and the image processing dialog closes. Now you can see the structure and the gray value image in the 2D view. The structure is now displayed in red. This is the default color for material 1 in Geodict. The black part behind is the gray value image. So at the moment the structure and the gray value image are shown at the same time. You can also toggle them on or off, so either up here under structure you can uncheck the checkbox and the structure is disabled, or you can also disable the volume field and only see the structure. You can also re-enable both to compare them. What I just saw here, that we might have to reset the color bar because the contrast is not very good, so go under volume field and here at the color map click on the edit button, so color map edit, and again we just drag the thresholds here for the histogram. You can just pick the red boxes and it should look a lot more nice now. Then if you're fine with it, just click on close. I re-enable the structure and want to have another look in the 3D view. So 2D is selected up here, now click on 3D and wait until it updates. Again, you can rotate the structure with the left mouse button, so click and hold the mouse button to rotate and click and hold the right mouse button to zoom inside of the structure. If for some reason you're not happy with the segmentation, you could redo the segmentation. For this, you can see the current volume files in the project area on the left. Since Geodict 2023, multiple gray value images can be loaded. The file gray values number 1 is the image that we loaded at the beginning. I will just show it shortly. If I disable the structure and double click on gray values number 1, you can see that this is the noisy image. If I select the other image, the one with the 2 number 1s, you can see that this is the filtered image. If you're not happy with the segmentation, you could select the first one, then right-click it, select then open it in image processing and redo all the steps for the segmentation. However, we don't need this now because we're happy with the segmentation. This means we don't need to click on open it in image processing. Additionally, we also don't need the gray value images anymore. Therefore, we can right-click on the field and just click Remove. We could also right-click on volume fields and select Discard volume files. You're asked if you're sure about this, and you can just click Yes. There is nothing deleted from your hard disk. This just means that the data is deleted from the main memory and not shown in the visualization anymore. Now I re-enable the structure up here on its tab, and now we can see the structure again. Now we tweak the visualization a bit. Under the Camera tab, select Show Outlines and Show Halo. Draw Halo helps to improve the contrast, and the outlines draw little outlines around all the grains in the structure. Now we want to analyze the grains in our structure. For this, we want to use the module GrainFind. You can find it here at the top under Analyze. Just go under Analyze, GrainFind. Now the module is changed from Import GeoVol to GrainFind. From the submodules, we select Now Identify Grains. Then click the Edit button to edit the parameters. First, we want to change the result file name. Just change it to cathode NMC identify grains. We don't need to change the remaining parameters because they are already fine for what we need here. For example, we want to keep the current structure for the initialization. Alternatively, you could also use other kinds of fields, but this is just not what we need here. We keep the minimal grain diameter at the default of 2 voxels, which means that each distinct grain has to have this minimal diameter. In general, we recommend to keep the default here because this leads to good results in most use cases. Only in case that the results are not good with the default value and you have further information about the grain diameters in your structure, we would recommend to change this parameter. You can also keep the option to reconnect fragmented grains. The algorithm in GrainFind tends to oversegment the grains, and with this option you make sure that the grains do not get too small. We also want to keep remove grain fragments at the domain boundary checked. Grains which touch the domain boundary are often not contained in the domain completely, and this means that they disturb the statistics of the analysis. For example, if only half of a grain is contained in the domain, its diameter is not represented correctly. For this structure here, this setting is especially useful because it contains so many grains that it doesn't matter if several grains at the boundary are removed. Now let's switch to the Output Options tab. In here, please select the option to save the grain diameter distribution as a GSD file. With this file we can visualize the grain sizes later. Then just click on OK. And click the Run button to start the computation. This computation should take around a minute on this structure on these computers, so we just wait until the calculation is finished. Now the computation is finished and the result viewer with the results file should open. Just maximize the window to see all the information better. In the grain find result you really get a lot of information about all the grains in your structure. For example, the total number of grains in the structure is calculated. In this example here you get around 4000 grains in the structure. Additionally, you get a lot of statistics about the grains and their diameters and much more information. We can't cover this in depth in this workshop, so please switch now to the grain visualization tab. First, select Load Grains as Index Image under the section Grain Segmentation Results. This file allows us to visualize all the segmented grains in the structure. Just click on the button Load G32. A G32 file is a 32-bit index file. It's a gedit format. In the window which pops up, keep everything as it is and just click OK. You're now asked if you want to set the structure to invisible. This makes sense, so click yes, otherwise the structure would interfere with the grain index image. Now minimize the results viewer and then you can see the grain index image in the viewport. You can directly see that the grains in the structure are nicely separated. You can zoom in and then have a deeper look at all the grains in the structure. I think it looks quite good. You can also see that grains which are connected are nicely separated. On this grain here you can see the effect of the grain reconnection threshold. You can see that the smaller grain is connected to the larger grain. Since the interface of both grains is larger than the given threshold, both grains are then connected to one grain. Now let's switch again back to the results viewer. Now we want to load the grain size distribution. Again, you can find it under grain segmentation result. Go to load size distribution and then click on load the GSD file. In the pop-up window, keep again everything checked and click OK then. Then minimize the results viewer again. At first we only see a blue box. This is the case because the grain size distribution is shown in all materials, especially also in materials which contain no grains. For these materials the grain size distribution is 0 and blue is here the color for 0 with the current color map. To disable that the volume field is shown in materials where no grains are, switch to the volume field tab. In the second box there is an option visible on material IDs, and there disable the grain size distribution to be shown in the pore space. Then rotate the structure a bit to update the visualization. There are then still some artifacts left. Here at the boundary you see a lot of blue half grains which have a size distribution of 0. This is the case because we unchecked the option to keep the grains at the domain boundary, and in these places here we have material, but this material is not analyzed as grain. We can also get rid of this artifact by thresholding the volume field. For this, just choose the slider Threshold By under the Volume Field tab and turn the slider slightly up. This threshold has the effect that the volume field is only shown in places where it is larger than the threshold. Now you can really see the analyzed grains in the structure. If we zoom in and then hover the mouse over one of the grains, we get a tooltip which shows the equivalent diameter of this grain. In this case here it's 1.47 times 10 to the minus 5 meters. At the other end of the spectrum you find the small blue grains, which have only a diameter around 2.3 microns. Now switch again back to the results viewer. Now finally we want to have a look at the plots in the results viewer. For this, switch to the Results tab. Then, under the Results tab, select the Plots tab. In there you get a lot of plots, clearly too many to explain them all now. Therefore, we only want to have a look at the diameters plot. So select Diameters under all the Plots tabs to switch to the Diameters plot. This plot shows a histogram of the analyzed grain diameters in the structure. We can see several peaks in the histogram, one at around 8 microns, another one at 10 microns, and a third one at around 13 microns. So far about grain analysis in this workshop. Now we go into another break, which takes again around 10 minutes. After the break we will start with another structure and do some fiber analysis. So see you again in 10 minutes.